Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give the introduction to maximum and minimum problems and how differentiation is applied to solve this kind of problems. So, based on what you have seen in the previous subtopics, all the informations or knowledge are useful and can be applied to solve optimization problems. For example, optimization problems can be in minimizing the cost or maximizing the profit. It could also be about minimizing the transportation time. It could also be about maximizing the areas and also maybe about minimizing the distances. So those are some of the examples related to the optimization problems. Now, I think the most challenging task in this section is to convert the problem into something that is imaginable and turning it into a proper mathematical function. Why do we need this function? Because then this function will be used in finding the maximum value or the minimum value. How can the maximum and minimum values can be obtained is by differentiating this function. Um, Now, in this section, I'm just going to give you two simple optimization problems related to finding the maximum value and minimum value. The reason I'm doing this is just this can be considered as introduction to optimization problem, and you will see that later on if you study a more advanced topic related to mathematics, which is optimization methods. In this topic, you will be seeing a lot of more sophisticated techniques related to solving the maximum and minimum problems, and those are, for example, response surface modeling, deterministic optimization, stochastic optimization, just to give a few examples on that techniques. Okay, right. Let us look at the first example here. So a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. So based on this first sentence, you can sort of imagine that it has a length of 2,400 feet of fencing available and wants to fence off a rectangular area that borders a straight river. And then if you go on and read the next sentence, he needs no fence along the river. That means there is no fence along the river. So what are the dimensions of the field that has the largest area? So the interest is to find the largest area, and what are the dimensions that will give the largest area. Now, if you imagine this problem, it will be to have some sort of a straight river. This is a straight river. Okay, so this is the river. Now, so he needs to fence off a rectangular field. So we are going to have a rectangular field. This is a rectangular field, but he doesn't need the border. He doesn't need a fence along the river. So maybe that is how we can visualize the problem. And I'm going to call this length here as L. Okay, and this one is the width of the rectangular area. And similarly, because this length must be equal to this length, this is going to be called as W as well. So we need to find what is W and what is L. So these are the dimensions of the field. Okay, so in order to perhaps understand what's going on, I'm just going to illustrate a few simple examples related to this rectangular field. So let's say that you have, you can imagine a possible value of rectangular field. For example, if you have the dimension of, for example, this is 2000, you're going to use up all the 2400 feet of fencing. And if this is 2000, that means you are left with 400 feet of fencing. You can divide that equally. So this is 200 and this is 200. So therefore, the area here, if you see, area is just 2000 times 200. So 2000 times 200, and you will get that the area is 4 3 zeros, 2 more zeros. So you will get that the area is 400,000 feet. Now, how about if we draw another rectangular area? So let's say maybe this is 800. Okay, but then if I draw that, it is not a rectangular, so but never mind. So this is 800. So if this is 800, you are left with 1600. So 1600 divided with 2, then this is no more rectangular. This is going to be a square area actually. But you can see, if you do this, you will get that the area is going to be 800 times 800. So 8 times 8 is 16, 2 zeros, another 2 zeros, so the area is 160,000 feet. So this is larger area compared to this one. Well, what else? Maybe this is not considered as rectangular actually, so this shouldn't be considered into our discussion, because if you consider this dimension, this has become a square area rather than a rectangular area. So let's consider another example. So how about if we have let's say we have this 2200. So if you have 2200 as the length of the rectangular area, that means you are only left with 200 feet more, which can be divided as 100 feet on this area, on another 100 feet on this fence on this side. And so based on this, okay, so 2200 plus 200 will be equal to the amount of fencing that the farmer has, which is 2400. Therefore, area in this case is 2200 times 100. So that will be equal to 2020, double zeros and double zeros. So that is 220,000. So still, this has a larger area compared to this one. So that is just to give you the idea on how different dimensions will give different area, and our job is to find what is the dimension such that it gives you the largest area. Now, in order to do it systematically, we need a function. We need a function that tells you about the area. So we need the mathematical function that tells you about the area, because we are going to maximize that function. Okay, so now we all know that if you have a rectangular area, the area is going to be described by length times with the width. Okay, so you can find the area by multiplying the length and the width. So we are going to have a problem here, because length is something else, w is something else, so we need to be able to have only one unknown variable here. So we also have another information that is related to this 2400 feet of fencing, where I can create a mathematical equation that says therefore L plus 1W plus 1W, so L plus 2W should be equal to 2400. So this is another important fact, whereby we can actually replace what L is. So based on this, I will know that L is going to be 2400 minus 2W, and we're going to use this and substitute into this formula, mathematical function. Okay, So this is the mathematical function that we are going to focus on, and we are going to substitute L with 2400 minus 2W. Okay, so I'm going to proceed with that. A is equal to 2400 minus 2W times W, and you can say that next we can expand it. If you want, you can have 2400 W minus 2W squared. So this is a quadratic function. Now I hope that you do understand, when you have a quadratic function of, let's say, if you have a function where you have ax squared plus bx plus c, this is a general quadratic function. The graph is going to be either like this or like this, depending on the value of a here. If a is negative, the graph is going to look like this. If a is a positive value, the graph is going to be looking like this. Now on this graph, you can see clearly that this is going to be this is a negative value. The value of that is -2. So therefore, if I sketch the graph of a, it is going to look like this in general. So it looks like this, and clearly you can see that there will be one point here where it will give a maximum area, because this is the area function. So there exists one point here that will give you a maximum value of an area. And how to get that? You have to differentiate this function with respect to W, and you will find the point W. Okay, so that's what I'm going to do next. I'm going to differentiate that. So I'm going to differentiate dA with respect to dW, and based on this I will get 2400 minus 2W. So differentiate W squared, you will get 2W. So this is equal to 2400 minus 4W. So now I'm going to set this result equals to 0. So now dAW is equal to 0. Therefore 2400 minus 4W is equal to 0. So negative 4W equals to negative 2400. So therefore W is going to be equal to 600. So W here is going to be equal to 600. This is also going to be equal to 600. So how about L? So L is going to be equal to 1200. So L is going to be 1200. Oops, I have extra 0 over there. Okay, 1200 because of that. Okay, now based on this dimension, maybe you can go on and check what's the area. So based on this dimension, the area is going to be 1200 times 600. So 12 times 6 is 72. Double 0 and double 0. So the area is going to be 720,000 feet. Okay, feet square actually. So feet square, I actually missed this. This is actually feet square. Okay, right. So so this is the answer. So W is equal to 600. Therefore we can say that based on this, you can write down the dimension. Therefore the dimension is going to be, for the dimension of L times W is going to be 1200 times 600. So it gives the maximum area of 720,000 feet squared. Okay, right. Okay, I think that's all for now. Thank you very much for watching. I'll see you in the next video with another example related to maximum and minimum problems.